Yes, it's rather an unusual thing for an engineering professor to do. But I'll say a few words about some of the things that I did. But thank you for the introduction. And on behalf of my colleagues, the faculty and the staff, I want to congratulate you again. You've been congratulated many times today, but congratulations again. This is quite an achievement. I have much in common with many of you here today, with the graduates and with the parents. With the graduates, I was the first generation to go to college. I beat out my cousins. I had a couple who were older, but I beat them out. My parents didn't finish high school, and my father wasn't so keen on me going to university. I remember him telling me about, what right does a son of mine have to do about going to university? And I was not born in this country, which is the case with many of the people here. And I am a parent. 2 of my children have graduated from NC State University, and I know what it feels like when they graduate. And raising children and eventually seeing them graduate is like a roller coaster ride, but today is one of the good days, and you tend to think that it was worthwhile putting up with all of the things you did when they were teenagers. My 3rd child is doing electrical engineering. He's at UNC Charlotte, and he's in 2nd year down there and doing quite well. Of course, I had to bribe him a little bit. I said he could be a co-author on my textbook if he gets through. But most of my remarks are going to be addressed to the graduates. So you have entered a profession which is known for its intense job satisfaction. Indeed, it is hard to explain to others what we do, really. We know what we do. We do most of our work in our minds. And when people ask us and grill us, we may have to say that we're designing the next smartphone or we're making sure our internet works correctly. But most of our work is done in our minds. We do abstract thinking at an incredibly high level, higher level than any of the other engineers do. Absolutely. Well, this is definitely the best branch. So one of the most powerful concepts that the US introduced to the world was the concept of inalienable rights, the right to life, liberty, and the pursuit of happiness. And as engineers, we enjoy those rights more than nearly anyone else. And we are in a position where we can enable other people to enjoy those rights. So last night I revisited some of the old adages about engineering. So the ones about why we're so happy. So I'm going to tell you what I found. So a couple of questions. So one of them is, which occupation has the lowest suicide rate? Well, number 1 is presidents of the US, because they have a 0 suicide rate. But after that, it's engineers. So which profession, or any job category, not just whether you've got a degree or not, which profession has the highest marriage retention rate, the opposite of divorce rate? Number 1 is clergy. They do very well. And after that, it's engineers. And it's almost impossible to find an engineer who doesn't enjoy their job. Engineers don't watch the clock for it to come to 5 o'clock and go home. They really enjoy what they do. We are very creative people. We're the most creative of people, but we also have an incredibly strong science background. Anyway, those are all indicators of happy people. So we're happy people. But we are the most creative people on the planet, and that has a lot to do with it. Now, Albert Einstein had a son who did engineering, and he was really upset initially with him doing engineering instead of science. But he turned around during his life, and he had this quote, "Scientists investigate that which already is. Engineers create that which has never been." That's an amazing thing to be able to do that. Yes, artists do it too, but we get paid. James Michener had a similar quote, "Scientists dream about doing great things and engineers do them." I really enjoy my life. I have the best job in the world, and I hope you are able to say that too. Especially if you don't commit suicide, and especially if you stay married. So not only are engineers happy people, we make the world a more secure place. We make it more secure for other people. We enable other people to be healthier, happier, and yes, richer, because we are the economic engine. We make things possible. We give even unskilled people good jobs. We really believe that we make a difference and we enrich the lives of others. Your joining our ranks is no accident. If you did engineering at nearly any other engineering school in this country, I could say much the same thing. Engineering is taught much the same way at many other schools. I think there's a difference in the level of dedication of the faculty, but it's essentially the same idea. We have taken you from people who are incredibly good at calculus and science and a few other areas. Well, you're still good at that, but we've also turned you into very creative people. The whole process was designed to turn you into creative people. Anytime faculty have tweaked with that magic formula, we don't produce engineers who are quite so good. But you are very creative people. Whether you've got a bachelor's degree, a master's degree, or a PhD degree today, you are very creative people. The most important work I have done in my career is related to roadside bombs. So I'm a microwave engineer. I love circuit design, which is a very pragmatic part of electrical engineering. But following 9/11, the terrorism attack on 9/11, I dedicated myself to trying to do something about terrorism. Now, for those of us who were in the US at that time, we remember that time with profound shock. We were all really shaken to the core. There are many people who stopped going to work, and some of you aren't old enough to remember some of that, but many people stopped going to work. I talked to some patent attorneys, and for a 3-month period, the number of patent applications dropped tremendously, and the many other indicators that our innovation level dropped. But I took on September the 12th, a dedication to try and do something. And I'm going to say a little bit about what I learnt on the way through there. My biggest problem was that I had no idea what to do. I wanted to do something, and I think everybody felt as though they wanted to do something. I had no idea what to do. Well, when the US went into Iraq and Afghanistan, and the roadside bomb problem became really quite significant, I knew that that's something that I could work on, because I was really good at circuits and fields, and of course faculty members are known for not being humble, so I thought I was the best in the world at it, and well, we'll see. So we developed techniques, and by we, I say my research group, which included undergraduates, it included master's students and PhD students. There were about 30 of us at the time. We developed ways to measure incredibly tiny signals in the presence of other large signals. So that's fundamental research doing that. And we were about several thousand times better than any of the national standards labs. We just figured it out. We still actually have the record for being able to measure the smaller signals. What that enabled us to do was to find most roadside bombs and to stop them from working. Seems strange how you connect all of that. But they're the things that really came in to me. You know, I had my various student helpers doing various pieces, making sure that they could do stuff that they could openly publish and openly talk about. But pulling everything together came down to me. So we did a pretty good job, and it's used everywhere now. Many countries use the ideas that we had. So the main thing that we did at that time was really developing ideas. Yeah, we developed some very specific things to do, but we developed some ideas, and we went out there and started educating engineers in companies and in the government about these ideas, and we changed the way people think. Just as we did with you guys as you came through. We changed the way you think. And many of my colleagues have done similar things. Doing original research enables us and forces us to come up with original ideas and ways of thinking. And when we teach you, we try to present those ideas to you. In my particular case, I have taken the ideas that I've done, which are, you know, many of them are well, the ideas aren't classified. How they're used is classified. Taking many of those ideas, and I teach them in my classes. And so do my colleagues. These ideas go from the lab, the research labs, into the classroom within a year or so. So I want to tell you something about my experiences in developing ideas. I think I've become rather well recognized for coming up with original ideas and doing things differently. And I want to talk to you about how you develop ideas from nothing. So when you're really in a position where you don't even know what problem to solve, how do you do it? So I learnt a few things on the way. So I have 7 points I want to make. Number one is diversity. So I believe very strongly in diversity, and this is all about coming up with ideas. If you sit in your room and read the same textbooks and talk to the same people every day, I doubt that you're going to come up with new ideas. You need to be in a situation where you are forced to be uncomfortable sometimes. If you develop a design group, you want a group of people from different countries. It's one of the things that makes the US very good. We want people from different countries. We want graduates from different schools. We want men and women, and we want people with different upbringings. That, to me, seems like a minimum. Number 2 is reading, and that includes technical reading. Read outside your area. Don't just read what's comfortable. Read stuff that pushes you and stretches you all of the time. I believe a lot in travel, in going to conferences. And if you go to a meeting, whether you travel out of town and go to a meeting or a conference, or you go to meetings inside your company, or maybe you go outside to conferences sponsored by the IEEE, make sure you learn something from every talk that you listen to. Don't waste half an hour, pretending to sleep. Make sure you learn something from everybody you listen to, which includes me, which is the most important thing you're going to learn today. Okay. So travel is very important. Travel and talking to others. And just walk up to people. You are engineers now. You're at the top of your game. You can walk up to people and engage them in technical conversations. Learn something from people. You have to give yourself time to think. You have to reserve some time. And these days, people work very hard in companies. Maybe some of that time is, on Saturday afternoon. Spend some time thinking. Let it all come together in your head. Force yourself to think differently. So you need cues to help you think differently and be forced to think differently. Now, one of the common things people latch on at the moment are bio-inspired ideas, bio-inspired circuits, bio-inspired whatever. Well, I think that's a really good thing to force you to think differently. It's not important that we get it right. We know that biology and the human mind solves problems differently than the way we engineer solutions to these problems. To try and make yourself think about how bio-inspired or how biology solves problems just pulls us out of our common way of thinking and makes us think differently. So again, it's not important that we get it right. We just need to be forced to think differently. Number 6, give back to the community. That may seem a little bit strange. How does that help you develop ideas? Well, what I've found, and I've volunteered a lot technically and volunteered other ways as well, but what I find when I have volunteered technically is that all the strongest engineers volunteer. It's amazing, really. All the people you admire and do great things, they volunteer. And one thing that happens is that people who volunteer are more likely to talk to you if you volunteer than if you don't. I mean, you don't volunteer to try and get that, but that is what happens. And that certainly helped me tremendously in my career, just being able to talk to the best people. You don't have to try and study a paper, go and ask them what they're doing now. What you read in a textbook or read in a paper is from years ago. Go and ask them now what matters. And I've written a lot of papers, and I know that I write a paper to make sure it gets published, not necessarily whether I totally believe in it or not. Sure, that's a little secret. And finally, number 7, I do not think that there are truly any new ideas or any brand new original ideas. I think most ideas are the synthesis of other ideas, and you have to be exposed to as many ideas as possible and spend a bit of time thinking and let those ideas ferment, and it'll help you develop new ideas. Today we have people graduating with a bachelor's degree, a master's degree, and a PhD. To the bachelors, you have entered an occupation with the most creative and the happiest members. We're all members of that group, so welcome. You are also in a special situation where you can make others happier. What could be better than that? You will create jobs, you will make people more secure, and by doing this, you will have a rewarding life. To the masters, over the last year or two, you have done 3 times as much engineering as you did pursuing your bachelor's degree. You're in a position now where you can solve problems at a level that you couldn't solve before. Maybe that'll encourage some of the bachelors here to get their master's degree. To the PhD graduates, boy, you've been in school a long time. We have taught you how to do research, and we've taught you how to develop original knowledge, something which is really hard to do. Many lay people think that research is like climbing a mountain, and when you get to the top, you are finished. But we know it's not like that at all. It's more like digging a hole, and where the ground is soft, you keep on digging, and where the ground is hard, you have to move on to another hole and start digging. But the trick is knowing when to move and when to keep going. And to do that, you need to do an apprenticeship. So Austin Pickles is here today. He's one of my PhD graduates, number 36. And Austin, you're very important. You're not just a number to me. But I had my PhD with a supervisor who also had a PhD, who got his PhD under somebody else, and there's an academic lineage. In my particular case, and I actually share the academic lineage with Paul Franzon over there, who's trying to dress the same as me. Okay. And if you go back through our academic lineage, you go to Lord Rayleigh, and many of you have come across his name in courses you've taken. And you may know another person in our academic lineage, and that's Isaac Newton. So you may have heard of him. And going back before that, Isaac Newton got his PhD from somebody who got his PhD from Galileo. And actually goes back into about 1400 when there was a self-made person who figured it out himself. He's a mathematician, and he developed himself. But it is extremely rare that people can go through that process and develop their PhD on their own. So speaking to all of my graduates here, so you all belong to me and to us, my colleagues have similar academic lineages. We have been taught by those who have stood on the shoulders of giants. And this is how you've developed the ability to solve the toughest problems. You have benefited from a very rich tradition. Now, this brings me to the story of Cecilia the rabbit. Okay. So Cecilia the rabbit was outside one day eating grass in the sun, and along came a wolf. And the wolf asked the rabbit, or told the rabbit, "I'm going to eat you." And the rabbit says, "No, you cannot. I'm working on a project on how the rabbit is smarter than the coyote, the wolf, and the fox combined." And the wolf said, "No, that's not true. Not true at all. I'm just going to eat you for my lunch." And Cecilia the rabbit said, "No, it is true. Let me show you." And so they disappear down the rabbit's burrow and they come back. They don't both come back, only the rabbit comes back. And the rabbit's outside in the sun eating the grass again. And a coyote comes along. The coyote grabs the rabbit and says, "I'm going to eat you for my lunch." And the rabbit says, "No, you can't. I'm working on my project about how the rabbit is smarter than the coyote, the wolf, and the fox combined." And the coyote says, "No, that's ridiculous." And the rabbit says, "No, let me prove it to you. Come down to my burrow and I'll show you." A little while later, the rabbit is upside, eating a bit of grass in the sun, and along comes a fox. Fox grabs the rabbit, about to eat the rabbit, about to bite into the rabbit, and the rabbit says, "No, don't eat me now. I've almost finished my project on how the rabbit is smarter than the coyote, the wolf, and the fox combined." So they disappear down the burrow. A little while later, the rabbit's outside eating grass, but no coyote, no wolf, and no fox. And along comes Ginger the bunny. And Ginger the bunny asks the rabbit, "What are you doing out here? Aren't you afraid that a coyote will come along, or a wolf or a fox, and eat you?" And the rabbit says, "No, not at all. I just explained to them that I'm working on my project, that the rabbit is smarter than the coyote, the wolf, and the fox combined." And Ginger the bunny says, "Oh, Ms. Rabbit, I know you're really smart, but I don't think that's right." And the rabbit says, "No, come with me. Let's go down at the burrow and I'll show you." So they both disappear down the burrow, and as their eyes adjust to the light, first of all they see some bones, a pile of bones. A little while later they see a lion. And the bunny asks the rabbit, "Ms. Rabbit, who's that over there?" "That's my professor." So the moral of the story is your project doesn't really matter. What really matters is your professor. Well, the faculty and staff are very proud of you today. We have guided you over the last few years, but you've also put your trust in us. We have made you in our image, but more than that, more than just our image, We're a diverse faculty. We've made you into something even greater than us. My final honour is to introduce you to the secret handshake of NC State electrical and computer engineers. Now, you've already been introduced to the first part because it's a two-part handshake. I'm going to introduce you to the second part and then we'll put it together. So I'd like you to take your right hand. It's important that it is the right hand, okay? And arrange it like this. This may be familiar to you. This is Fleming's rule of electromagnetism. And this is the electric field. This is the magnetic field. And this is the direction the fields are going in. Now, we really like abstract thought because we know all around this room the electromagnetic fields are wandering around. And if it wasn't for that, our cell phones wouldn't work. And if we didn't visualize that, we would not be able to develop the design for a smartphone. We have to believe in something that we cannot see. So let's put it together. Okay, you got this? Okay. I'm proud to be an NC State electrical and computer engineer. Okay, my colleagues and I wish you the best of careers, and thank you.